everyone. So I'm going to talk about 12.4. Just like before, it would be so much better if you would look through your book, the section in the book, before you watch this video. This video will make a lot more sense if you look through your book first. So I want to start by talking about what a z-score is. So your book gives you this formula, z equals x minus x bar over s. So remember, x bar is the mean, the sum of all the data values, and then you divide by how many there are. S is the standard deviation, and that's that, big table and the weird formula with the sigma. And then X is whatever data value you are considering. So here's what's really important though. This is what I'd like you to write in your notes, is what is the Z? Like, what does it actually represent? And so what we're going to do is we're going to use the standard deviation as our unit of measurement. So if you think back to like algebra, when you would do graphs, you would, do like a little XY axes, and then you would, maybe on the x-axis you go up by ones, 1, 2, 3, etc. And maybe the x-axis represents time in seconds or whatever. And then maybe the y-axis represents a height. And so the y-axis you go up by like tens, 10, 20, 30, 40, 50, etc. So that's your unit of measurement. It's the unit that you're going up by. And so we're going to base all of that on the standard deviation. And so that's really key. So if you look in your book, we're going to talk about example 1. So maybe pause the video, open your book real quick. So example 1, it talks about the male adult heights of North America. And it says that the mean is 70 inches. Okay, and then the standard deviation is 4 inches. So, what if someone is 74 inches tall? Okay, so let's say Bob is 74 inches tall, okay? His z-score would be 74 minus 70 over 4. So this is my x in this problem, in this case. 70 is the mean, 4 is the standard deviation. So I'm plugging in my values. And this is 4 divided by 4, which is 1, okay? So what that means is, if I were to ask you, like, okay, well, how many inches above the mean is Bob? Well, he's 4 inches bigger than the average. Oh, okay. How many standard deviations is that? Well, the standard deviation was 4. So that's 1 standard deviation more than the mean. Okay, so watch this. Let's do another one. Let's say that Billy he's short. He's only 62 inches tall. Okay? So again, what if I asked you like, well, how much below the mean is that? Oh, 8 inches. Oh, okay. Well, just before we calculate it, how many standard deviations is that? 8 inches is 2 standard deviations, 2 times 4, right? So if I calculate my z, watch this. My x is 62, my mean is 70, my s is 4, so that is negative 8 divided by 4, which is negative 2. Okay, so how many standard deviations below the mean is Billy? 2. 4 and 4 is 8. That's how far below the mean he is. It's negative because he's below the mean, not above the mean. Okay? So if someone is taller than average, that would be a positive z-score. If someone is shorter than the average, that would be a negative z-score. Okay? So keeping that in mind, let's talk about the 68, 95, 99.7 rule. So there's this rule. It works for any normal distribution, okay? So the total percentage of everything underneath the curve, okay? If I were to take the area under my bell curve, my total area would be 100%, because that would be 100% of my data. That makes sense. What's really great about this is it all has perfect symmetry. So everything is totally symmetrical all the way around. So the percentage less than the mean is about 50%. The percentage greater than the mean is also about 50%. Okay? So if I were to do my bell curve, my mean would be right smack in the middle. Less than that would be 50%. More than that would be 50%. And then here's this crazy rule. If you go one standard deviation out from the mean, both directions, so mean is in the middle, one standard deviation less, one standard deviation more, this accounts for about 68% of all of your data. Always. If you go 2 standard deviations out from in both directions, that's about 95% of all of your data lies in here. If you go 3 standard deviations out, that accounts for about 99.7% of all of your data. Okay? So we're going to play with this a little bit, just playing with the areas and the percentages. So, for instance, if all of this is 68%, what's 68 divided by 2? 34. Good. So there's 34% in each of these parts because of that symmetry, okay? Similarly, if we were to take the 95 and cut it in half, so if you want to take out your calculator, 95 divided by 2 is 47.5. So here, I don't know where to write this. This is about 47.5%, and this is about 47.5%. Okay? So you need to be able to kind of play with the numbers a little bit. But the beauty of doing class this way is if you struggle with this a little bit, you can watch this video 2, 3, 4 times if you need to. So, again, going back, I want to talk about example 1 in your book. So again, the mean is 70 inches. The standard deviation is 4 inches. So watch how we're going to set this up. I'm going to put my mean in the middle, 70. And then I'm going to count up by 4s. So 74, 78, 82. Okay? So I'm just adding 4 each time. And then I'm going to subtract 4 each time. So 66, 62, 58. I want to point out the z-scores for all of these. So the middle, the mean, the z is just going to be 0. Okay? And then you go 1 standard deviation up, 2 standard deviations up, and 3 standard deviations up. So your z is 1, 2, and 3. Okay? So say what was z is 0.5 or a half. Well, halfway between 70 and 74 would be 72. Okay? So if z was 0.5, your value would be 72. So you can have decimal z-values as well, okay? So now if I go in the other direction, this is where z is -1, where z is -2, and where z is -3. So you're always, on these problems, you want to set up your standard deviation. You want to draw your curve. You need the picture. Please draw the picture. And you're going to set up your mean, and then add the standard deviation, and then subtract the standard deviation 1, 2, 3 times in both directions, okay? So now, what if we wanted to know, like, what percent of North American men are between, say, 66 and 74 inches? Okay. Well, from the mean, you went 1 standard deviation in both directions, so that's 68%. All right. So what about between 62 and 78 inches? So now we've gone 2 standard deviations in both directions. So that's 95%. And then what about between 58 and 82 inches? That would be 99.7% because you've gone 3 standard deviations less than and greater than the mean, okay? So, let's get a little bit more complicated. What about just what percent of North American men are less than, we'll start somewhat easy, 70 inches. So if you remember, we said if it's less than the mean, that's half, that's 50%. So the mean was 70, so this is 50%. Okay? Now what about what percentage are less than 74 inches? This is getting a little bit more complicated. So watch what we can do. Okay? I'm going to try to do this without destroying my picture. So we said earlier, well, let me start with this. So less than 70 is 50%, okay? So I'm going to mark that, 50%. So that's everything except for that region, right? So I'm doing everything from 74 less. Everything from here on is already 50, so we're good there. Now what is this? Remember we said earlier, if all of this is 68, each of these is 34. Okay? So from 70 on is 50. Between 70 and 74 is 34. So total, if I add those together, that's 84%. So you've got to be able to play with the percentages a little bit. Let's do one more of those. Percentage of men less than 62 inches. Okay, so let me erase my markings. So, and I want to say, like, there's more than one way to do these, however you think about it. I'm just showing you one way, okay? So less than 62 inches. So here's how I think of it. You might have a better way. So I know between 62 and 78 is 95%. So that leaves these ends that we call tails. It leaves the left tail and the right tail. Well, if this is 95, then the tails are the extra 5. But each one is only half of that, right? So what's 5 divided by 2? 2.5. So what this means is, since from like this middle part is 95%, that leaves the tails total being 5%, which if I cut that in half, that means that each of these tails has to be 2.5%, so that all of it still adds up to that total 100%. Okay? We're going to do just a couple more. So what about more than? There's almost no difference between more than and less than on how you approach them. But let's say we wanted to know what percentage of North American men are more than 82 inches. So, I'm going to do the same thing I did the last one. So, 82 is 3 standard deviations above the mean. Okay, your Z is 3. So that means that I'm looking at this 99.7%. So all of this in between 58 and 82 is 99.7%, which leaves not very much. So if you do 100 minus 99.7, that only leaves 0.3% on those little tails. Okay? But each of those tails is only half of that. So what is 0.3 divided by 2? It's 0.15. So if from 58 to 82 is 99.7, what that leaves is 0.15 on each tail, which would then add up to your total 100%. Okay, so your answer for this one would be 0.15%, not very much at all. Okay, so practice this. This is going to take a little bit of practice. Some of you are going to be really good at this right off the bat. Most of you are going to have to practice it a little bit. Send me your questions. We're doing a study session soon, so yeah, we'll work through it, but just keep plugging along, guys. I'm so proud of you. You're being so adaptable, so flexible. You're doing awesome. I miss you so much. I would much rather talk to you than a camera, but love you guys.